Hello, hello, and Happy New Year. It is the first video we are going to do for 2019. Sorry it's been a while since we put anything up. This one's going to be a little different, kind of cool too. This is a customized engine that a customer of ours ordered from the USA. His name is Brandon, and he is building a first generation car that was an original 12A vehicle. But now he's going to put a high boost 12A engine, turbocharged, into the car that's using FD side housings and a custom intake manifold and a big ass turbo. So we had to build this engine real strong. So you're going to see all the parts we've modified specific for this build as we normally do. And then we'll walk you through the preparation, and eventually, as we always do, you'll see us put the engine together on the engine stand. All right, so just a little rundown of what we're going to do here. Again, so we have used some FD end housings, and then we have specifically chosen a automatic rear iron for the purpose of, if he gets to the power levels he's thinking he might, it allows him to do the side mount starter T56 upgrade, a transmission swap more or less, where if he used the original manual transmission rear iron, he wouldn't have that option. So we've gone the distance to install the automatic rear, which we'll show you in a bit. And then we've had to modify some rotor housings because Mazda discontinued the 12A rotor housings some 15 years ago. And finding brand new ones or ones of good enough quality for a build like this is near impossible. So we are going to show you the ones that we made ourselves, not from scratch, but we'll talk about it when we show you. Those are the sort of the two key elements of building this custom engine. Beyond that, the customer has supplied another very rare part, which is, again, almost impossible to find this day and age. Not only did he send us 12A turbo factory rotors, but he sent us brand new 12A low compression turbo rotors. Really tough find, really cool item to see pop up in our industry, and we're going to use those in this build as well. So we'll show you all the strength mods shortly, and thanks for subscribing and liking. See you soon. Okay, so here are the main pieces of the engine. These have already been prepped. We have shown you guys many times before the port work we do on our CNC machine, the studding process, the lapping, the clearancing, and so on. So this is going to be a demonstration of the work already done, and then we'll take you through and do the build in a minute. So as a recap, FD, REW, end housings, including the automatic rear. We have designed this engine as a full Bridgeport motor, not very common. This guy's pretty adamant about going all out. Brandon said, I want to throw everything I can at this and do the maximum modifications to yield the most power. So hence the full bridge, the studding for strength, and so on. So this is our CNC primary port with the Bridgeport. Then we have our automatic rear iron, again, Bridgeport, big secondary port, big runner. Now, the automatic rear iron is unique in that it has a side mount starter that bolts on here, and then the other half to the bell housing. So you do need an automatic rear bell housing from a third generation or Cosmos automatic transmission to make that work. And then of course there's an adapter kit that adapts that bell housing to T56, for example, like a Camaro 6-speed transmission. Lots of strength in the transmission, but this is the only way you can accomplish that is to use this automatic rear iron. So a special piece. Of course, we've got all the stud holes already done. We're going to be putting in an FD high pressure oil regulator. And we've already gone ahead and modified some FD gears. So these were originally 13B REW gears, which we then ground down to 12A height. So these are a custom gear that we actually converted. We use the FD because we get the multi-orifice oiling from all the way around the bearing. And then of course these are drilled and chamfered as well, so this engine will get maximum oil flow. Front and back gears done respectively the same way. Then we have one of the real tricky parts of this build. So we started with a brand new pair of GSLSE 13B rotor housings. And one of the reasons we did that is because when you take a 13B and make it thinner, you will see that there is very little material left on either side of the exhaust port for aluminum when it goes from 5 millimeters on each side narrower. So this particular rotor housing uses a 12A type sleeve, which allows that extra material. If we were to use, say, an 86 up or even an FD matching rotor housing, we would have such a small amount of aluminum on either side of the exhaust port. It would be dangerous from the heat. You might get leakage, and it just wouldn't be as rigid. So we have cut these rotor housings down on our CNC machine. Put the dowel pin hole back in. Obviously, as you can imagine, any 13B rotor housing that you remove any surface work on, like this dowel pin hole, has to be put back in. So we did do the groove for the dowel pin O-ring on both sides. And these are just now naturally thinner for the 12A. Then we've gone ahead with our race exhaust port on both these housings. And last, of course, we have the notches on both sides of the rotor housing because it's a full bridge motor. So primary and secondary on each housing. Again, the race port about as large as we can go, where this sleeve will still facilitate the kind of exhaust flow that we need. So brand new SE rotor housings modified to 12A. Beyond that, the entire engine has been done for our slip fit studs. We've talked a lot about our studding process. We are putting in shorter 12A studs, same ARP nuts, and this engine is going to be extremely robust and strong, not just in terms of the twisting that we take care of by putting in our studs, taking the load off the pins, but because this is even a shorter block than a 13B and these short little fat half-inch studs, it's just going to be a very, very strong unit. So internally, if we switch over here to the rotors, 12A eccentric shafts by nature are very, very strong again because of their shortness, and back in the day Mazda wasn't so leaning towards trying to save weight, so they don't have the lobes all drilled and they haven't removed extra material. These were just a nasty, strong shaft to begin with. My personal opinion is the 12A shaft is stronger than any factory 13B shaft on the market, so we won't have any issues here. We've just polished it and the shaft is ready to go. The rotors, customer supplied, brand new factory turbo. Tough to see, but there's a T stamped in each combustion pocket to represent turbo. These are front and rear designated because of the pear shape of the combustion chamber. Brand new. All we've done is race clearance the faces and fit them with brand new seals. We've got the solid corner seals for strength, and we have the rotaryengine.com 3mm treated seals, just like the 2 millimeters we use in all of our other 13B builds, with a very, very heavy 13B spring cut down to 12A length. So these bearings are brand new, obviously, and we're going to be getting lots of oil pressure and flow to these bearings. So we have pretty much covered all bases to deal with all strength and performance modifications of this build. We've also gone ahead and matched up the front and the rear counterweight to these rotors. So we are using an FD front counterweight with the large thrust assembly, nice bonus there, to match the deep recess on the front gear, which you'll see in a minute when we start filming the assembly. The front plate is already mounted to the engine stand. And large thrust assembly, and then both counterweights spun to match this rotating assembly. So I think that's about it for, if I think of anything else, when we're doing the build, we'll talk you through it then, and we'll see you at the engine stand. Okay, so we've got our front iron mounted to the engine stand and ready to assemble Brandon's 12A turbo custom engine. One of the things I just wanted to explain too earlier was about the oil modifications that we've done. We did talk about the fact that we're putting in the high pressure FD regulator. We've drilled and chamfered the gears. We've got a different front spring to put into the front cover. Because we're using the FD front iron, we have no choice but to use this FD oil pump. So again, nice bonus that we've got a high volume pump, and we've machined out all this area in the oil pump galleries right up to the land for the best flow to these multi-orifice bearings and FD gears. So what we'll do now is we'll flip the engine over, and we already have all of our O-rings mounted in the irons. So we're going to just go from start to finish from here. And pass that bottle. Let's put a little bit of lubrication on this gear. We've already got lubrication inside all the bearings, including the rotor bearings. And now we get to handle our beautiful 12A turbo rotors, which is, again, something we do not run across very often. So all these rotors are packed with brand new seals and springs, and we're going to likely assemble the apex seals with the loose end facing towards the middle iron, for the simple fact that we have got a smaller port on the primary. It's a little less time that the end piece needs to be suspended when it's going over the bridge. So it only makes perfect sense, especially when you have that availability, to go ahead and, this is one problem with these solid corners, they spin super easy, and I know my spring is out of place here, I can feel it. Yeah, it's twisted. There it goes. So put that back in. And yeah, so the end piece is already glued onto the apex seal, so we will have the availability to put the front rotor ends up towards the center, and the back ones, the ends will go towards the other half of the center. So now we're just going to put our silicone on and get rotor housing number 1 in place. So the GSLSE rotor housings, the brand new housings that we're using, do only come with the coolant seal grooves in the housing. When we do a normal 12A build and use those customized brand new housings, you have a need to put the O-ring grooves back in somewhere if you're going to thin the rotor housing, because as you can see, now that we've done the machine work to make the housing thinner, we've machined out the factory O-rings. So we are not in need of putting those O-ring grooves back in, simply because we already have O-ring grooves in the FD irons, which is a nice bonus. However, when we do 12A rebuilds using these custom housings that we make, our CNC machine does have a program built in to put those seal grooves back into the housings. And just for a little bit of further information, not that it's really that important or even relevant in this particular build, but there is not enough material on a portion of the GSLSE rotor housing to put the groove back in. In fact, we have no choice but to put the grooves back into the iron. And that has been something we learned years and years ago. Again, these solid corner seals make it a little bit tricky sometimes for an easygoing assembly. They like to slide around and pop out because they have no rubber plug in the middle. So we're just going to put a little blob of Vaseline on the top of that in case that thing wants to fire loose. Yeah, these ones are tricky because the fact that they are sprung under such heavy spring pressure. All right, now, Mike, I will have to get you to take a look when we put down the center plate to make sure we don't lose an end piece and an O-ring doesn't fall down. And you will obviously have to hold the shaft too. So let's get that up to where it's good. You want to be right about there. All good?
Yep.
Okay, so you watch. There. Now back down. And just pay attention to your ends and to the O-rings. Good?
Good, yeah.
Perfect. Okay, we're past the hurdle now. Still the engine stand and the... Okay, so let's get our back rotor down now. Here, and hopefully these corner seals stay somewhat in place. A little odd doing it from the angle I'm in right now, but we should be good. Put it there. Straighten these out. Yeah, those corners really like to slide around. Brand new rotors too, so we don't have any issue with worn holes. They just like to move. That's all there is to it, but we're straight where we are right now. So we should be good to put this other housing down. Let's go ahead and get some more silicone here. Yeah, now once again, for those of you who watch our YouTube videos, we have a video on our channel which is labeled 3-rotor FB Sleeper. And it is a very high horsepower engine that we built, and we also installed it into the FB car and did some transmission changes and axle and rear end modifications. The issue really is, how do you put that kind of power to the ground when you've got such small wheels and such a narrow car? It just seems almost unreasonable. I don't want to get my customer Brandon here all hot and bothered over my comments, but I look at a build of this level and I think to myself, again, first generation chassis, this kind of power, how on earth is the power going to go down? Now, the bright side is knowing that Brandon has talked about, or at least elected to put the rear automatic iron on for the 6-speed Camaro transmission. At least there's some light at the end of the tunnel there for possibly him doing something similar with the differential and putting in something V8 or muscle car orientated as well might almost be key or even mandatory. So I hope Brandon's thought about that. I'm sure he has. He's gone to the extent to put together a pretty insane project here, an engine build. Much better. So one more to go. Okay, now what we got to do is start putting in our studs. So I'm gonna, you guys won't be able to see what I'm doing, but that's okay. I'm gonna just get the back of this iron facing me so I can see the bolt pattern. There are some important locations to put studs in first, and they would be as follows. So looking from here, we have to put in this one and that one And we need to put in the top one is second there. And 2 more. This is partially because it's an automatic and primarily because we're doing studs. So we're going to put in, actually, I think, if I'm not mistaken, we need to do this one also. Skip a hole, this one. So those are the studs that need to go in first. So what we'll do, we'll just quickly run those in, since these are relatively easy when they're sticking up this distance. It's actually when the rear iron is on, it's a little bit more challenging to get the studs on. You'll see. This way here we've got lots of room and lots of stud to bite onto. Now in the future we've decided that we're going to put an Allen key in the back. Now I personally like running them in with my rigid tool. The difference is if somebody orders one of our stud kits and they don't have this tool, they are going to be a lot better off if we have our Allen key in the back. And that's exactly where we're going on the next production run. So, but I'm perfectly fine making use of these studs while they're still in my inventory for in-house stuff, and the mail order stuff all going to be the Allen key. So I think for the most part, if you think about it, this engine is brand new. You know, it's a new rotor housings. Even though they've been machined, they're still brand new. The chrome is still brand new. The FD irons, refurb and lapped, equivalent of brand new, and rotors brand new. You know, so this is one very high quality build, in my opinion. By the way, we've had a few comments on our part 1 and part 2 studding video. And always appreciate comments. Apologize that I don't always get back to people right away. A little behind on my YouTube stuff, but I'll catch up soon. What I see is there is still a lot of objection to that people have to you know, what's so great about studding your way. There's probably a lot of people out there who are getting tired of hearing me say the same thing over and over. But I have learned that I started asking around customers who either sold their cheap stud kit on eBay, Craigslist, Kijiji, and ended up going with a proper stud kit like ours. Just a recap, machine work being the most critical factor next to the quality of the stud kit. And what I was asking those people is what motivated you to buy the stud kit when we all know, or at least I've tried to educate people to know that those 10 millimeter studs that replace 10 millimeter tension bolts, complete waste of money, almost a gimmick, a money-making scheme for some of these shops that sell them. There are some small benefits with cylinder head pressure, I guess, like an upgraded bolt. But in terms of acting like a stud, they certainly do not. And I think that the most common answer was, well, because the experienced Rotary shop who sold us the stud told us or showed on their website that it was an upgrade and a way to make your block a lot stronger, which again goes back to I don't want to say false advertising and pick on these guys, but the marketing behind it. You know, I guess people wanting to take the word of the shop, and I guess those shops probably know that. You know, if we say it's good, it's got to be good. But there's just no truth to it at all. 90% of the stud kits out there are not stud kits, and 90% of the kits that people sell are just complete gimmicks, and that's all there is to it. So I probably will stop talking about that and won't say it again. Again, I'm sure some people are getting tired of hearing it, but my take, you guys all know my take on it, very simple. A real stud kit does not have a real stud kit does not have the large, sloppy hole that you find from the factory. That's the whole purpose of doing it, is to take care of that and get rid of that. So hopefully, you know, people watch a video like this enough times and see the quality. Makes me real tempted to demonstrate it one more time. Slip fit, no movement, okay? No extra space around either side of the stud. That's a stud kit. That's what a real stud kit does. So, moving along, sometimes, especially because of that tight tolerance and lack of clearance, which we aim for, installing this rear iron with the studs already in like this can be a challenge. But because our machine work is great, well, that's what you get. You get a perfect fit top to bottom. Just going to move the crankshaft over a hair because we are, can I have the nut in that basket please, Mike? Because we have to tip this just ever so slightly to the right. And again, that's the deal when you just have just aiming for the dowel pins. The gear will catch the rotor gear first. You'll feel it click, and then the plate will just fall onto the pins. When you've got all these extra studs now that we're sort of shish kebabbing to get on top of, that becomes a much trickier task to get that. So I would advise you to come around here and watch that one piece from this side. And sorry if this is seeming a little boring for you guys right now. The video is intended, the one I put in there, the video is primarily intended for the customer, for Brandon. But we, there we go. See that? See how it just dropped just like that? So we elected to you know, put it on our YouTube channel with his permission. But that is how you know, we're winging it right now. We're talking as we're going and trying to keep you entertained. You'll see some of the hiccups as we go, and this is by no means our most professional video, but hang on. Oh yeah, those ones. Pardon me. Sorry, Mike's way ahead of me. Must be getting late. So we're going to throw in our long bolt here, our short one here, and I'm going to start running down these other studs to catch up with the ones we've already done. And these ones, of course, have to catch higher up in the thread, but nothing we can't handle around here. Mike's just going to put the last couple of O-rings on and washers. We just wanted to speed through that just because it's boring and get to the final torque sequence here. We're just going to put a little bit of Loctite on all the ARP nuts, and Mike's been putting some Vaseline on each O-ring. That way, when we're torquing, should the washer decide to spin, it's not going to tear up the O-ring. It's going to be nice and lubricated for any number of degree that it twists. And I would say it's highly unlikely we'd get a full rotation out of it, but you know, even 5-10 degrees, even a couple degrees, the O-ring's only going to stretch so much before it decides to tear. So always lubricate things like O-rings when you have a rotating piece going on top or you're torquing something down. It's a good idea. There we go. 2 more. And there we go. Actually, I'll use this one to get some good speed on it here. So what we're going to do is we're going to just get some preliminary torque on the middle bolts, the 3 and 9 o'clock positions, so we can break past that layer of silicone that's getting a bit of skin on it. And eventually what you'll do is you'll see it just squeeze out the side, and it's still nice and wet, but it's just good to get some good pressure. And it doesn't take a lot when you're dealing with a design like an engine sandwich, where you have a stack, just a few foot-pounds of torque, not even real torque, just enough to overcome the crush on the coolant seals. And that's when tolerances become very, very tight and accurate, much like the way this engine was designed. So you won't get, you know, you need that tight tolerance between cylinder heads and cylinders. And that's where it goes. Okay, so now we just got some preliminary torque on all the nuts, and we're just going to go through the torque sequence. We are actually running out of time on our card, so we are going to have to call it quits here. But what we will obviously do is we will go around the entire sequence of the nuts, and we will torque everything evenly and go to our final torque spec that we specify for our studs. And this is a wrap. So hope you guys enjoyed it, and we'll see you again next time real soon.